Hello and welcome back. It's another beautiful day on this amazing planet we call Earth that gave us everything we needed and the tools and everything else to make life, to make us. Hello and welcome back to Focus. Okay, so I want to talk about life, but more specifically, quality of life. Even more specifically, let's say quality of life for limbless or amputees. So I've got a few stories that, from my point of view, are the culmination to the beginning of a new branch of technology, let's say. And if anything, amidst the backdrop of this AI Armageddon, which has many world leaders scrambling to discern whether or not this technology is good or bad for us, like the UK's Prime Minister flying over to America to have a sit down with, President Biden as to whether or not this is good for our future. But like I said, amidst the backdrop, I've got a few stories from my point of view which are remarkable. In the sense that, one, we've got a company that's created, believe it or not, a version of, how do I say this? A robotic arm, but not just a robotic arm that you can control with muscle movement via EMG signals. But I'll get to that eventually. Also, another company, believe it or not, has also created a similar technology in the sense of what they call soft e-skin. It's a neuromorphic sensory motor loop embodied by a monolithically integrated low voltage soft e-skin, which allows this electronic filament, you should say, or skin, to go onto a person's body, finger, and allow them to also control a robotic arm or a robotic appendage of some form. One of these companies has started off as a Kickstarter, and they have actually vowed that for every 5 backers they are going to donate a robotic arm to a limbless child. So it's going to be a donation. So our future generation growing up is more or less going to be a civilization of soon-to-be cyborgs. And how can I not mention the fact that Elon Musk's brain chip has gotten, the go-ahead for human trials, which sets another precedent. But, we'll get to that. But once again, as far as I'm concerned, as always, technology is amazing. The way it branches off, integrates, eventually evolves. Let's take the wheel, for example. It started off as a simple wooden circle with a long pole attached to the center, which eventually turned into another wooden wheel, and it simply had its weight reduced in the sense that it had spokes. Everybody knows what a spoke is if you've got a bicycle or see a tire. And it evolved again in the sense of the early motorized vehicles. They had metal framed wheels with rubber outlaying, also with thin metal frames. Still look like a bicycle, many of them, But once again, it evolved as well to carry what we know as modern vehicles. To carry the extra tonnage, they increased the width. They started creating them with more solid iron materials. And look, even now to this current time, you have over at least 10 different versions of what you would call the wheel, in the sense that they are created in different, how can I say this, irons, materials, different polyurethane compositions. But that is technology in its most simplest form that many people wouldn't even realize is technology at its finest, in the sense that the wheel itself also evolved into what people would call spokes or sprockets, which is what is used to power these amazing devices or future robotic appendages. But once again, like I said, Earth is amazing, the people, what we do, and what we have achieved. And like I said before, our history is pretty vast and we're making it pretty fast. So I'll try to keep it brief. Okay, let's go. Did you know there's a 60-foot tall giant robot in Tokyo? Actually, there's two. And the second one can actually move. But I'll save that for another episode. For now, let's start small with something really useful. A robot you can actually control. But first, I've got to tell you a little about the company and the man behind it. SparkFun is a company founded by a man called Nathan Seidel while he was still studying electrical engineering in 2003. It's an interesting story how he went from learning how to use one device to making his own. So, what is SparkFun? It's an online electrical retail store that sells nearly everything from Bluetooth and GPS wireless tech to sound, motion, and biometric sensors. A wide range of development tools from cryptographic microcontrollers to machine learning and AI platforms. And of course, all the buttons, switches, LEDs, and LCDs you could possibly need. Many of these come from well-known brands such as Bosch and Nvidia, to their own unique ones like the MyoWare and SparkFun. And in their own words, SparkFun has been helping turn ideas into reality. Whether you're creating a smart weather station, exploring the frontier of machine learning, building a robot for school, or prototyping your first or 10th product. But I want to talk to you about one of their own, the Umio EMG muscle sensor module, and something they like to call the Arduino project. Now, muscle sensor technology has been around for a while, and many researchers have used EMG or electromyography sensors for speech recognition and achieved recognition rates of between 68 to 97%. An EMG sensor is similar to an ECG or EKG sensor, heart monitor, you must know about those. But an EMG sensor itself detects electrical activity from a muscle using conductive pads placed onto the skin. Every time the muscle is activated, individual fibers within it receive electrical impulses, causing them to contract. Now, it's worth noting that there are two different types of electrodes, surface and needle, with needle electrodes being broken down into another 3 categories. I mentioned this all together because at the same time this tech was proving its worth in the medical community, and to the many people it helped regain some semblance of speech, a voice, something no one could really put a value on. Nathan Seidel saw another unique use of the technology. Well, it's not the first time the MyOS sensor has been in the news. With a video emerging last year in November of it being used to make an RC or remote control car turn left and right by the user in the video, squeezing his left and right hand or opening and closing his hands. This year, the company has changed the game and has taken leaps and bounds forward. In comes its new and improved Umyo EMG sensor, which is produced by their friends at Advancer Technologies, and the Arduino project, which they describe as a simple demonstration of what the sensor can achieve. Talk about being humble. They have released a video showing the sensor being used to wirelessly transmit signals to a robotic arm. Now, the video is pretty good. It shows someone moving their fingers, thumbs, and it is moving, pardon me, the fingers on this robotic arm. Now, I'm going to quote something from the actual article when I came across it, okay? Now, it says, the project was designed as a simple demonstration of what the Umyo sensor module can achieve. It's fitted with 3 separate Umyo PCBs to detect movement from the wearer accurately. Each finger of the robotic arm has 2 tendons. These are connected to, what did I mention? A wheel that is operated by a servo. The servo determines whether or not to curl or uncurl the fingers. Now, like I said, it's amazing how something as simple as the wheel is being used to create something that can change someone's life as much as this can. Now, I can say groundbreaking and game-changing because the cost that goes into creating one of these. And actually, the reason I really say this is because the company is working in partnership with a company called Limbless Solutions, a group whose mission is to build 3D printed, and I love this name, myoelectric prosthetic arms and donate them to children in need. I mean, it's one way to envision a robotic future, but I love the whole idea and the concept that they are going to be donating one of these prosthetic arms, 3D printed, I might say, to a child in need. And this is for every 5 backers they have on their Myo Kickstarter. And also, it's worth noting that if you have to include the price of a 3D printer as well, and the filaments needed to go into it. Oh, I forgot to mention that the technology itself, the MyOS sensor, is open source, which means you can pretty much create it yourself or use it and not have to worry about the copyright pattern or the use of the device for your own soon-to-be outstanding invention. But it allows anyone who needs a prosthetic limb, be it an arm or a leg or hand, not only to make their own, but be able to make it incomparably unique in not only terms of design, but capability. In the video, they use 3 sensors to accurately pick up the movement, but anyone's welcome to use even more sensors to try and get a little more accuracy out of it. If you're even braver, you could experiment with using the needle electrodes, which from what I've found out so far feels a little like a needle injection, and that's about it. Whether or not you feel it when it's in afterwards whilst you're moving your arms is another story altogether. But the reason why I say this is game changing is because the average price of a prosthetic limb in the US especially ranges from between $5,000 to $70,000. And for many, that is not really a figure that they can actually manage. But if you've got to use this technology, and even if you have to include the price, as I said, of the actual 3D printer, you could achieve all of this for maybe less than 500, even less than 1,000. But the point is, this could actually change the sway of how much power the medical industry has, which, from what I've gathered so far, there's an interesting documentary on Netflix. I haven't checked it out yet, but if this is anything to go by, it could be a revolution in terms of medical science, or what can I say, open medical science. People being able to treat themselves without having to go through, let's say, the big medical organizations, hospitals, private practices. This grip that they have on society is kind of stifling at times. The amount of money that goes into surgeries, procedures, medications. Big Pharma has a lot to answer for, but no one can really make them. But what's really intriguing about this is the potential of this technology. I mean, what we can actually be able to do with it. It's a whole nother story. But like I said, our history is pretty vast, and we're making it pretty fast. There's actually a lot of information in regards to all of this, and I actually left quite a bit of it out. And I know it seems like I actually went on for ages and ages, but you know what? Like I said, Earth is amazing, and the people, I mean, look at the kind of things we come up with. What next? Okay, so I might have gotten the description of our next subject slightly wrong. So let's give it another go. I came across a story in The Independent which basically said that scientists created an electronic skin. Okay, so they've created what they call a neuromorphic sensory motor loop embodied by a monolithically integrated low voltage soft e-skin. Alright, our skin provides a protective layer for our bodies. It also enables detailed sensory feedback and soft interactions with our surroundings. Wang Et devised a prosthetic electronic skin that incorporates organic semiconductor transistors and has no rigid components, thus mimicking the mechanical aspects of real skin. At the same time, it can sense external stimulus such as temperature and pressure and encode these stimulus into electrical pulses. The authors showed that the prosthetic skin could evoke neural firings at the motor cortex in a rat in vivo, which means either inside of the rat or inside of the lab conditions, which triggered toe twitching. I mean, it's kind of remarkable. And after doing a little bit of research about it, as always, it's a little bit much, but I've got to tell you, as much as I can as far as I'm concerned. But it was first invented in the 1960s. The 1960s saw the advent of the artificial touch sense when researchers used pressure transducers fitted on hand prostheses to generate stimulus. These developed sensors applied to the skin with the help of electrodes and implants provided direct neural stimulation. Since then, it went to, I think it was in the early or late 1980s, 1985 is when General Electric or General Motors, or General Electric, sorry, GE, built the first sensitive skin for a robotic arm using discrete infrared sensors placed on a flexible sheet at a resolution of equal to 5 centimeters or near to 5 centimeters. Now, this new breakthrough, the material that's used in it is graphene, and has also been shown to be a suitable material for electronic skin applications as well, due to its stiffness and tensile strength. Graphene is an appealing material because its synthesis to flexible substrates is scalable and cost efficient. Now, since its conception, graphene in itself has been a remarkable material that has changed how we do many things and affected our lives, but no one actually is all that aware of it. But a lot other electronic components and materials went into it. Some nanoparticle, silicon, carbon nanotubes, oxide, permeativity, dielectric material, and of course nanocrystalline material. But the electronic skin itself is composed of a 4x4 tactile sensing units, which contain 3 layers. The lower substrate, a polyimide substrate or a PI substrate, the piezoresistive layer, the piezoresistive layer, and the graphene or the polyethylene terephthalate film, and the PDMS bump layer. This electronic skin has the advantages of high sensitivity, large measurement range, and vast response time, and has high particle values for the progress and development of artificial intelligence, rehabilitation medicine, and obviously many, many other fields. Okay, so it's no surprise that the same scientist who was involved in this recent breakthrough also published a paper on the 25th anniversary of e-skins. And in that article, I'm just going to read an abstract for you. It says, human skin is a remarkable organ. It consists of an integrated, stretchable network of sensors that relay information about tactile and thermal stimulus to the brain, allowing us to maneuver within our environment safely and effectively. It's because of this basically, interest in large area networks of electronic devices inspired by human skin is motivated by the promise of creating autonomous intelligent robots, and what I'm more interested in, biometric prosthetics. Among other applications, the development of electronic networks comprised of flexible, stretchable, and robust devices that are compatible with large area implementation and integrated with multiple functionalities is a testament to the progress in developing an electronic skin, or e-skin, akin to human skin. E-skins are already capable of providing augmented performance over their organic counterparts, both in superior spatial resolution and thermal sensitivity. They could be further improved through the incorporation of additional functionalities, example chemical and biological sensing, and desired properties, example biodegradability and self-powering. Continued rapid progress in this area is promising for the development of a fully integrated e-skin in the near future. Now, this being the really distant future, I won't exactly say near future, it's not like in between then and now there weren't other breakthroughs, with scientists in the University of Edinburgh also releasing a version of e-skin, which they coined as being able to give physical self-awareness to robots, basically, and in their terms, it was slightly different for the fact that this one could work better with stretchable robots. The stretchable e-skin is used on soft robots to provide them with a level of physical self-awareness similar to that of people and animals. Now, that was one that was made earlier this year. I think last year in June, Friday the 3rd, 2022, just for historical purposes and references. There was another article released. It said, robots gain a sense of touch with new artificial skin. The printed skin helps robots sense temperature, pressure, and even toxic chemicals. Now, this one was slightly different in the sense that they used 3D printing, I believe, to create the circuits or the infrastructure or the electronic skin needed to give the robot, I think in this case they used mannequins, or well, I say mannequins, they used a version of a mannequin that had something more akin to a material that was more like our skins, which allowed the robots, or allowed the sensors, the 3D printed sensors, to detect a variety of different temperatures, pressures, and even whether something is toxic, according to researchers at the California Institute of Technology, or Caltech, for any of those of you who know. But just for the record, for an engineer, or a scientist, or a medical student, this must be something out of a comic book or even a movie. But as far as I'm concerned, this isn't the future. This is the now. This is what we can use right now to actually help so many people. And even then, there's many innovations along the way that can actually be done with it. But going down this rabbit hole left me truly in awe and inspired towards the future and what will become. But in any case, the reason I'm saying this is because I was more than spoiled for choice in options of articles. I mean, just when this one article was released, I think several others were released on the same day. I'm pretty sure I mentioned that it was scientists from Stanford in England, I'm pretty sure, who created the e-skin. And the first story I came across, as I mentioned before, was in The Independent. So I'm gonna take up a little bit of your time, and I'm gonna say, and I'm gonna ask for your apologies from now. But I'm going to read them both for you. The first one I came across, which was the one from The Independent, and the one from the Stanford News Service. And you know what? For posterity, I think I'll read the one from Stanford first. So, soft e-skin generates nerve-like impulses that talk to the brain. May 18th, 2023. A single multi-layer soft and stretchable material with integrated nerve-like electronics can sense pressure, temperature, strain, and more, just like real skin. Mechanoreceptors in human skin can sense the delicate weight of a butterfly, feel the heat of a nearby flame or a cool drink, understand whether a hand is raised in a fist or a peace sign, and count the pulse of a loved one with a gentle touch. Engineers eager to create artificial electronic skin have so far been able to fashion soft, flexible materials that mimic each of these remarkable senses. But never have they created a single sheet with skin-like materials that can directly talk to the brain, until now. While previous efforts required rigid electronics to convert the sense signal into electrical pulses that the brain can read, researchers at Stanford University have produced soft integrated circuits that convert sense pressure or temperature to electrical signals similar to the nerve impulses to communicate with the brain. The researchers hope someday that those signals might be directed to implanted wireless communication chips in the peripheral nerve to allow amputees to control prosthetic limbs. Which is why I mentioned that Elon Musk's brain chip has, got to go ahead. In any case, These researchers hope someday that those signals might be directed to implanted wireless communication chips in the peripheral nerve to allow amputees to control prosthetic limbs. Other potential uses might include new age implantable or wearable medical devices. The e-skin is soft and stretchable while also being able to mimic sense of touch and run efficiently at a low voltage. I believe it's at a voltage of about 5 volts. I think similar to that of real skin. A quote from Dr. Bao. We've been working on a monolithic e-skin for some time. The hurdle was not so much finding mechanisms to mimic the remarkable sensory abilities of human touch, but bringing them together using only skin-like materials, said Zinan or Hinan Bao. Apologies if I got that wrong, sorry. K.K. Lee, professor in chemical engineering and senior author of the study appearing in the journal Science. Much of that challenge came down to advancing the skin-like electronic materials so that they can be incorporated into integrated circuits with sufficient complexity to generate nerve-like pulse trains and low enough operating voltage to be used safely on the human body, said Wei Chan Wang, a doctoral candidate in Bao's lab, who is a first author of the paper. Wang has been working on this prototype for 3 years. Layers of technology. The goal was a soft integrated circuit that could mimic the mechanism of sensory receptors and run efficiently at a low voltage. Unfortunately, Wang's first attempts demanded upwards of 30 or more volts and could not realize enough circuit functionality. This new e-skin runs on just, as I said before, 5 volts and can detect stimuli similar to real skin, he said. Artificial skin will be critical to new age prosthetic limbs that not only restore movement and functions like grasping, but also provide sensory feedback, proprioception, that helps the user control the device with precision. Not only that, but the sensory skin material itself must stretch and return without fail, time and time again, all while never losing its nerve-like electrical characteristics. The team invented a tri-layer dielectric structure that helped increase the mobility of electrical charge carriers by 30 times compared to a single layer dielectrics, allowing the circuit to operate at low voltage. Interestingly, one of the layers in the tri-layer is nitrile, the same rubber that is used in surgical gloves. The majority of e-skin is made of many layers of skin-like materials. Integrated in each layer are networks of organic nanostructures that transmit electrical signals even when stretched. These networks can be engineered to sense pressure, temperature, strain, and chemicals. And what that can mean in the future is unbelievable, but I'll get to that eventually. Each sensory input has its own integrated circuit. Then all the various sensory layers must be switched together into a single monolithic material that does not delaminate, tear, or lose electrical function. Each electrical layer is just a few tens to the 100 nanometers thick, and the finished material of half a dozen or so layers is less than a micron. But that's actually too thin to be handled easily. So we use a substrate to support it. A substrate is like the backbone or the foundation, let's say if you're building something, which brings our e-skin to about 25 to 50 microns thick, about the thickness of a sheet of paper, Dr. Bao said. It is in a similar thickness range of the outer layer of human skin, which consists of about, I think, 7 layers, something like that. the next generation advances. The system is the first to combine sensing and all the desired electrical and mechanical features of human skin in a soft, durable form that could be used in next generation prosthetic skins, and innovative human-machine interfaces to provide a human-like sense of touch, which basically means you could use this skin to feel what you're doing if you're controlling a robot, let's say with a 3D headset, virtual. But with their prototype complete, Bao, Wang and the team now embark on increasing complexity and scalability of the technology, adding wireless functionality and ways to interface with the brain and the peripheral of the body. Now, I've said it, it's more than amazing. It's what we will be able to do with such a technology. This incorporated with the Umio sensor. I mean, like I said, this is a branch of technology in the making. Like I said, all my engineers, scientists, medical students, I'm sure this must pique your interest. And even for all of you students who haven't even gotten to that level yet, I mean, come on. Wouldn't you like to be involved in creating something like this? Like I said, Earth is amazing. The people, what we can do, and what we are doing. Stay with me. Still with me? Fantastic. I want to talk to you about Neuralink, Elon Musk's brain implant company. It's recently won approval from the Food and Drug Administration to start testing its Link device on humans. So, what does the chip do? The brain-computer interface is fully implantable, cosmetically invisible, and designed to let you control a computer or mobile device anywhere you go. Brain implants developed by Elon Musk's company Neuralink have been approved for human testing. The safety of the devices previously came under scrutiny following reports of botched surgeries in animal test subjects, which I'm pretty sure you probably heard of. So, could this change the world? I mean, this incorporated with many others, Neuralink prostheses have the potential to aid people in the future who suffer from a variety of neurological conditions, particularly those in which there is a disconnection or dysfunction between the brain and the nerves of the body. In case that doesn't really make much sense, let's say you got a severe spinal injury. This would enable those with spinal cord injuries to move their limbs and could effectively cure paralysis, blindness, mental illnesses, maybe, and neurological conditions such as Alzheimer's and dementia. The long-term ambition is for the technology to allow humans to compete with artificial intelligence. What could this mean for the future? Musk points out that our thoughts move much faster than the fingers we use to type with, or the mouths we use to speak. Eventually, people equipped with a Neuralink device will theoretically be able to learn and communicate at the speed of thought, without any words needed to be even written or spoken. So, as always, the amount of information out there about this is nearly endless, and as far as I'm concerned, I can't talk to you about one without talking to you about the other. So I'm gonna mention a few articles, I'm gonna read them out for you in order of the most recent to the original article that spoke of Elon Musk's FDA approval. So, firstly, I'm going to talk to you about, I'm going to reiterate an article from the neurosciencenews.com. Interfacing minds and machines, an exploration of neural implants and brain-computer interfaces. Neural implants and brain-computer interfaces, or BCIs, have revolutionized our understanding of the brain and its interaction with technology. By translating neural activity into computational commands, they enable communication and control of individuals with motor disabilities and open up new avenues for cognitive enhancement and neuroprosthetic applications. Recent advancements are working to overcome the challenges of biocompatibility, signal fidelity, and long-term stability. This article highlights the potential of these technologies in improving human experience and their connection to neuroscience. Key facts. Brain-computer interfaces can turn brain signals into computer commands, enabling people with motor disabilities to communicate and control their environments. Invasive neural implants, including the Utah array and Elon Musk's neural device, offer high-resolution brain readings, but face challenges such as tissue damage and signal degradation over time. Non-invasive methods, such as EEG and fNIRS, offer safer alternatives for BCI applications, but most overcome obstacles related to signal quality and specificity. Just because I know I mentioned the BCIs and Elon's link, but the Utah array is a high channel count microelectrode array invented by Richard Norman at the University of Utah. Initially intended for applications in visual prostheses, over time it widely became adopted by the neuroengineering community as the gold standard tool for basic and applied research. The array costs about $6,000, not including other necessary equipment. Scientists are working on a smaller wireless version that would allow someone to use the technology at home and eventually wherever they are. The array gathers neural signals from up to 100 different channels per device, and it's the only BCI implant with documented long-term stability and safety in humans. It has been studied in dozens of patients for a total of more than 30,000 days, demonstrating groundbreaking performance. Neural implants and brain-computer interfaces, BCIs, are revolutionizing our understanding of neuroscience and broadening the horizon of human experience. By enabling direct communication between the brain and external devices, these technologies offer enormous potential to restore sensory and motor function, treat neurological disorders, and even enhance human cognitive abilities. This article delves into the principles underpinning neural implants and BCIs and how recent research and innovations are paving the way for unprecedented improvements in the human experience. Neural implants and BCIs, core principles. Neural implants and BCIs rely on the ability to record and interpret the electrical activity generated by neurons, the basic units of the brain's computational machinery. These technologies use a combination of electrodes implanted into the brain or placed on the scalp in non-invasive BCIs and sophisticated algorithms to decode underlying patterns of neural activity. This information can be used to control external devices, such as a computer, cursor, or a robotic limb. Advances in neural implants and BCIs since the first rudimentary BCIs were developed in the 1970s. Technological advances have significantly improved their performance. Recent innovations in electrode design and manufacturing have enabled more precise recording and stimulation of neural activity. For instance, the development of thin, flexible electrode arrays has reduced tissue damage and inflammation, improving the longevity and reliability of neural implants. Simultaneously, advancements in machine learning and signal processing algorithms have boosted the accuracy of speed of the BCI control devices. One study demonstrated a BCI that enabled a paralyzed individual to type at a speed of 90 characters per minute, significantly surpassing the previous record. Neural implants, BCIs, and neuroscience have not only shown potential and therapeutic tools, but also provide invaluable insights into the workings of the human brain. By recording neural activity from different brain regions while individuals perform various tasks or undergo experiences, scientists can unravel the neural correlations of cognition, perception, and or even, could you believe it, emotion. For example, a recent study used the BCI to probe the neural basis of decision-making processes. The researchers found that specific patterns of neural activity predicted the choice an individual was about to make even before they reported being aware of the decision. The ramifications of something like this goes beyond saying, but in any case, neural implants, BCIs, and the enhancement of human experience. Perhaps the most speculative and controversial application of neural implants and BCIs is in the realm of human enhancement. Elon Musk's company Neuralink aims to develop high-bandwidth BCIs that could enhance cognitive abilities such as memory and attention, and even allow for novel experiences like, would you believe it, telepathy or direct interaction with artificial intelligence. While these ambitious goals are far from current technological capabilities, they highlight the profound potential of neural implants and BCIs to transform the human experience. The intersection of neuroscience, engineering, and computer science embodied by neural implants and BCIs hold immense promise. As these technologies continue to evolve, they are set to reshape not only our understanding of the brain, but also the very contours of human experience. What we could discover about ourselves goes beyond saying. However, their development also raises significant ethical and societal questions that must be worked on very carefully. It's not just broken glass, it's not just hot coals. We've got to be very, very careful. But in any case, Elon Musk's Neuralink wants to put chips in our brain. So, how it works and who else is doing it? Neuralink's Elon Musk brain implant company has won approval from the Food and Drug Administration to start testing its device in humans, one of a growing cadre of neurotech pioneers with goals of merging humans with machines to treat a range of medical conditions such as paralysis, blindness, and depression, and enhancing, and they mentioned this many times, existing abilities like memory, or allow us to simply interact with computers by thought alone. Obviously, that's not something simple. Elon Musk's Neuralink is one of several companies pursuing brain implant tech that would allow us to communicate with machines or any other, I suppose, wireless or electronic device. Neuralink was founded quietly in 2016 and flew mostly under the radar until showcasing its technology in 2019, which I'm sure many of you can probably remember, which was an amazing video of a chimpanzee playing Pong, having one of these chips implanted into its brain, very efficiently, I would probably almost say. It is building a device that can directly interface with the human brain, called, as I mentioned before, the link. A sort of brain chip Musk has described himself as a Fitbit in your skull, and a robot that can automatically implant it like a kind of neural sewing machine. Its device makes use of ultra-flexible, tiny electrodes implanted directly into the brain to listen to the communication between neurons. Christine Well, a neurophysiologist at the University of Colorado, told Forbes, which could allow users to control a computer or other devices or communicate by simply thinking. Neuralink is the only company doing this, or even the most advanced. Brain implants for conditions like Parkinson's disease are already in widespread use, and similar firms like BlackRock Neurotech and Synchron have already started human tests, the former decades ago, but receives more media attention because it is well-funded and has a connection to Musk, rather than having a novel or technical astounding device. Columbia neurobiologist Raphael Youst told Forbes, by allowing the human brain to directly interface with computers and other devices, neurotech companies hope they can help people regain abilities lost through things like injury or disease. For example, a camera could be used to stimulate areas of the brain associated with vision to restore sight, or a robot limb could be connected to an area of the brain that controls movement. Bradley Greger, a neuroscientist and neural engineer at Arizona State University, told Forbes there are many different ways this can be achieved, meaning there is a lot of space for multiple companies to make a significant mark in history. In late May, Neuralink announced it had secured FDA approval to launch its first in-human clinical study. The decision represents an important first step that will one day allow our technology to help many people. The firm said, adding that it was the result of incredible work by the Neuralink team. The news comes after Musk, who sets notoriously optimistic timelines and has a history of prematurely celebrating success with regulators, predicted trials were 6 months away in November. It was not the first time Musk had predicted human trials were around the corner, and the FDA reportedly rejected an application from Neuralink over safety concerns earlier this year. The FDA took the unusual step of confirming its assent for Neuralink to begin human tests in a statement to media outlets. Though beyond noting it had greenlit human trials with the company's brain implant and surgical robot, it did not provide any more details past that. Neuralink has come under intense scrutiny over its animal research practices and is reportedly being investigated by the U.S. Department of Agriculture for potential animal welfare violations, which the company denies. It is also reported that the subject of my apologies. It is also reportedly the subject of a federal probe from the Department of Transport for allegedly transporting contaminated devices removed from monkeys in an unsafe manner. Musk's vision for Neuralink goes beyond what many in the field seem to be aiming for, and he is open about wanting not only to restore human performance where it has been lost, but to enhance or add even new functionality as well. Experts say using neurotechnology for enhancing humans raises obviously more profound ethical questions than just restoration, particularly as it would be used on otherwise healthy individuals. Greger said such goals are very speculative and are likely a long way away. Well, who is also on the scientific advisory board of neurotech firm Neuro1 concurred and said many limitations to current technology still need to be overcome, such as electrode breakage and the need to recalibrate algorithms regularly. Data gathering from people's brains will become a key issue, and there is a dire need for the better regulation and discussion in this area. Well said, particularly regarding large for-profit companies like Neuralink that stand to make insane amounts of money off of this type of data. Joost also believes there is an urgent need for regulation and ethical discussion for neurotech. The threat largely comes from companies developing non-implantable devices or brain-computer interfaces that are treated more like consumer electronics. Joost said rather than implantable devices that from the likes of Neuralink, which are treated as medical devices and are governed by strict medical ethics and robust regulations, Chile is the first country in the world to enshrine protection for the brain activity and its information, and should serve as an example for the rest of the world. Joost said, "The brain is not just another organ," he explained, adding that neuroscientists are increasingly able to decode brain activity. And I'm not sure if you heard, but there was also a story that mentioned how they put a few patients in an MRI machine and they played a variation of phrases, speeches, words, letters, and music to them. And since they knew what they were playing to them, they noticed which parts of the brain highlighted, which allowed them to accurately predict what this person was thinking, I think between 80 to 90% of the time. But just for the record, it was kind of easy for them to fool the MRI machine despite what they were hearing coming in through their ears. If they continued to think something differently, it did throw off this machine. And I'm going into a lot of detail, and yes, I know I'm digressing, but it is worth knowing for the fact that the technology is in such early stages that each scan is only tailored to each individual, meaning just because they used it on one person and they were able to determine what this person was thinking 70 to 80 or 90% of the time, it doesn't mean if they use the same algorithm on another person that they would be able to discern anything at all of what they were thinking. But as I said, I digress. Mental privacy is the sanctuary of our minds and should be protected at the global level. It's not clear when Neuralink's trial will begin or if and when it will ultimately launch a product. The firm said it has not started recruiting participants yet and will announce more information on recruiting soon. A patient registry on the company's website suggests Neuralink may be looking to recruit patients with certain types of paralysis, vision loss, hearing loss, or the inability to speak. Gregor told Forbes, starting human trials is a significant milestone to receiving FDA approval, which he said is mission critical for Neuralink. It is, however, the first step of many on a long road that has no guarantee of success. These are really early trials, often called early feasibility studies, that typically enroll less than 10 patients and generally last between 6 and 12 months. Well, who is also a former FDA official, told Forbes positive results would then allow Neuralink to start the larger trials needed to demonstrate safety and efficacy for whatever condition they are treating, which could last years. Rollout is years, if not decades away, Well said, once approved, however, it becomes a readily available treatment option similar to a heart pacemaker. 206,000.7 billion. That's Musk's estimated net worth according to Forbes' real-time tracker. He's the second richest person in the world, trailing only French luxury goods magnate Bernard Arnault. In addition to Neuralink, Musk co-founded electric car maker Tesla, the source of much of his wealth, and as well as rocket firm SpaceX and tunneling firm Boring Company. He also holds a sizable stake in the social media platform Twitter, which we all know because he made a lot of noise about that, and he bought it for 44 billion, and he changed a lot of things, and not everybody was pleased about that. But that's a whole different story altogether. But back to the original story in itself, when Elon Musk's brain chip company Neuralink says it won FDA approval for human trials. I'm sorry. Apologies for the length and time, but I feel like I would be amiss if I did not say or provide you with all the information in order for you to come up with or create a sound judgment. So, to the original article that, sparked it all off. Elon Musk's brain chip firm Neuralink has said it has been given the go-ahead to start carrying out studies on humans. Neuralink said in a tweet on Thursday it had won the approval of US Food and Drug Administration, FDA, to launch our first in-human clinical study. It represents an important first step that will one day allow our technology to help many people, it said. The company did not elaborate on the aims of the study or when trials start, but said it was not recruiting yet. Now, this was first posted on the 26th of May, Friday, 2023, this year. Musk, who last year claimed that the devices were so safe, this is why I had to reference this. He said the devices were so safe he would happily use his children as guinea pigs. I'd never do that. I don't care how safe it is. He hopes they will one day help conditions including obesity, autism, depression, and schizophrenia, as well as enabling web browsing and telepathy. The billionaire said Neuralink would begin human trials at least 4 times since 2019, but the company only applied for FDA approval early last year. The agency turned it down then. Major issues involved the implant's lithium battery, the possibility of its wires migrating within the brain, and whether the device could be safely removed without damaging brain tissue, and said the concerns needed to be addressed before sanctioning human trials. Neuralink, founded in 2016, and has been the subject of federal investigations. In December last year, it reportedly came under investigation for, like I said before, alleged animal welfare violations in its work. Claims it denied. But a total of 1,500 animals died in 4 years, according to a report leading to internal complaints that animal testing was being rushed, causing needless suffering and deaths. Musk increased pressure to accelerate development, though, staff said, leading to botched experiments that needed to be repeated. In one case, there was a report that 25 pigs, guinea pigs just stuck with me from before. I mean, his kids, who would say anything like that? In any case, in one case, 25 pigs were reportedly implanted with devices that were the wrong size. With a source telling Reuters news agency this was an error that could have been avoided with more preparation. Neuralink hopes the implant it is developing will help paralyzed people walk again and cure other neurological issues. Now, Earlier this year, Swiss researchers showed the potential for the technology. No. Or was it earlier last year? I'm not sure. But a paralyzed man from the Netherlands was able to walk simply by thinking it, thanks to a system of implants which wirelessly transmit his thoughts to his legs and feet. Now, I don't know if you came across that story, but what happened afterwards was neurons in this guy's back brains that were dormant or dead or disconnected before showed signs of firing. Basically, after the removal of the technology, he still had limited movement of his legs. Limited is putting it kindly. He could twitch his legs, but considering he went from having absolutely no mobility and then this device being implanted and having been removed, leaving him with some residual effect, like I said, it's amazing. Okay, like I've said, our history is pretty vast and we're making it pretty fast, so I'm going to keep it as brief as possible. The emergence of these technologies, or the re-emergence of these technologies, the Umio muscle sensor, the electronic skin, and in the form of Neuralink's brain chip and others, these technologies reintroduce, how can I say this, making life more livable, more accessible to those who have suffered severe injuries, from amputations to severe spinal cord injuries, to even people who were born with certain deficiencies like blindness or certain spinal cord deficiencies. It would allow them to be able to see, and there have already been many studies with biological implants, optical nerve implants, allowing blind users who previously had no use or no sight using their optical nerve to regain some true semblance of vision, which understandably would bring anyone to tears. But with this new re-emergence of technology, imagine a carpenter who lost his arm due to a severe accident. He could be, and the reason I say a carpenter in particular, because carpenters' work is precise. They groove and they smooth with the wood, and tactile sense is essential to that kind of work. Having a prosthetic limb fitted with an electronic skin that allows a carpenter to feel the wood whilst he is using it, whilst he is working with it, would not only reintroduce a skilled laborer back into a profession, but once again, imagine how you would be able to customize such devices. You could make it more bespoke to his profession, not just to himself. Obviously, these things can be detachable and interchangeable. Technology itself, innovation, and the way it integrates is what we look at specifically. Neuralink, in cooperation with electronic skins, like I said, can change how we interact with it to a completely different level. But that's still pushing far, far ahead. What about, let's say, a mine worker or an oil rig worker who's also had an amputation or a severe injury? They could be fitted out with a prosthetic limb that has one of the other sensors, one of the toxic sensors, one of the heat sensors, these prosthetic limbs as useful and how can I say this, revitalizing to one's life would not only be an added peripheral that they were missing, it would also be a useful tool in regards to their work. A toxic sensor working in a mine could detect carbon dioxide or various other gases being released throughout the Earth's crust, be it many of them. Either way, with these three technologies in cooperation, robotics on a whole can be pushed to a completely new boundary. Imagine a NASA scientist or a NASA technician basically controlling a robot. Yes, the information delay between Earth and Mars, I think, is something like 22 minutes or more, but allowing the user to control a robot with a 22-minute delay on another planet. Yes, I know that's far-fetched, so let's bring it back down to Earth. Allowing a user to control a submersible robot, or let's say a robot underneath the water, to carry out repairs on deep sea cables, internet lines, pipelines, on submersibles that can carry out repair work or cleaning work, removing barnacles on freighters, yachts, simple boats, trawlers, tugboats. Where this technology incorporated can go is unbelievable. And I actually cut this short, and I know I went on for over an hour, but there was another remarkable discovery, and they actually called it, or they said it caused an alert, a cyborg alert. AI robotic arms that can be attached to humans engineered in Japan. But that's a story for another episode. Unfortunately, it won't be the next episode, as I've already got what I wanted to talk about lined up. And the next one I want to talk to you about is dream jobs. From the truly grounded to the down to earth, to those that are truly out of this world, literally. But stay with me. And thanks for tuning in once again to Focus. For links to the articles, check out the episode description. If you want to leave a comment, check out the trailer description for the email address. For topics like these and more, check out future episodes. Like I said, the world is an amazing place. There's a lot going on, and sometimes we just need to take a moment to focus.